Hello, this is Mr. Rhodes. We're going to do a brief introduction today of an idea called conditionals. And I'll tell you right now, conditionals are just sentences. And these sentences are going to make the class look a bit more like English than math. And it'll take a little while for us to get it all together, why these are important for us. Also, a quick word to the person controlling the computer. I will give you some cues, when to pause, so make sure you do that, allowing people to catch up. So let's get right to it. As always, when things come on the screen, make sure you get them in your notes. A conditional. A conditional is very simply an if-then statement. An if-then statement could be something like, if it's too hot, then my ice cream will melt. And generally speaking, I think that's a true statement, that if I'm holding ice cream and it's a hot summer day, the ice cream is going to melt on my hand. So we need to talk about two different parts of this sentence. Now, I will underline the parts here and then move to the next page and actually get the definitions going. So the first part is going to be, it's too hot. And I just realized there should be an apostrophe there. This is called the hypothesis of the sentence. The hypothesis in this case is what's attached to the word if. And this is the idea or the condition that has to be met. Next, you have what's called the conclusion. And the conclusion is all the stuff attached to the word then. So, the hypothesis is the beginning. The conclusion is after the word then. And this is the idea that has to follow. As long as the hypothesis is satisfied, then the conclusion must follow. So let's go ahead to the next page and get some definitions of these, kind of summarizing what I just said. Hypothesis. This is the phrase attached to the word if. It is the condition that must be met. It is the condition that must be met. So unless the hypothesis is taken care of, the rest of the sentence is kind of null and void. The other part is the conclusion. The conclusion is the phrase attached to the word then. The phrase attached to the word then. And simply stated, once the condition is met, this is the idea that must follow. This is the idea that must follow. Please pause the presentation so people can catch up. Very good. At this point, we're actually going to use an example. We're going to use an example, and we will do some different manipulation of that example, paying attention very closely to the hypothesis and conclusion, because it is the key to all of it. So the first thing that we need to do is we need an example. We need an example. And our example is going to be if it snows, then school is canceled. School is canceled. So what we're going to do is we're going to assume that this is a true statement. And when we're talking about it snows, we're talking about a large amount of snow. So if it snows, then school is canceled. In this case, we have the hypothesis. And again, notice I didn't point out the word if. It's not underlined. And also the conclusion. So give me just a second. I'm going to select all of this stuff and go ahead and copy it because I'll be using it regularly. Now, if it snows, then school is canceled. So the first manipulation that we're going to do is going to be the converse. It's going to be the converse. To find the converse of a statement, we need to switch the hypothesis and conclusion. The hypothesis and conclusion. Forgive me, but I just realized I kind of missed something. And that is the letter representations of the hypothesis and conclusion. It would have really made sense if we would have used H and C in the English language. But this is an idea of logic. So considering logic, we have a letter to represent everything. And in that situation, we have the hypothesis represented as a P, and the conclusion is represented as a Q. Now, a little bit of history here. This is one of the uses of mind your P's and Q's, if you've ever heard that phrase. The other one is it's originated from the British pubs of mind your pints and quarts. So, we have P's and Q's. When things are in the normal order, it works out that P implies Q. And if we're going to switch that and make the converse, we will get that Q now implies P. We're going to switch the order of the hypothesis and the conclusion. So from our example, if I wanted to write the converse, I need to switch it snows and school is canceled. So it becomes this phrase. If school is canceled, then it snowed. If school is canceled, then it snowed. So notice what I've done. I took the original phrase and switched those two parts. That's all you have to do to find the converse of a statement. What used to be the hypothesis is now the conclusion, and vice versa. Please pause the presentation and allow people to catch up. Very good. Now let's see if this worked. Awesome. So we have the converse. It's time to move on now to something called the inverse. The inverse. The inverse is kind of similar to the converse, and it's in that it's a simple change. However, for this one, we're going to add the word not to the hypothesis and conclusion. Add the word not to the hypothesis and the conclusion. And forgive me, I just realized that looks awful. There, hopefully you can read that. So instead of it does snow, I'm going to change it to it does not snow. And instead of school is canceled, I will make it school is not canceled. This is called negating the phrases negate. So the letters that are involved with this will be P implies Q. Now understand, the direction hasn't changed. I've not moved P and Q, but I have negated them. So here's the symbol. It is a little squiggle. That is the same squiggle that's over top of the congruent statement, the congruent symbol. So it's squiggle P implies squiggle Q, and it is read as not P implies not Q. That's how you read it. Excuse me. I can't even speak. Not P implies not Q. This is the negation. Adding the word not to a sentence. So, pause just a second. See if the people in the room can write down the inverse of this statement. Remember, you're simply adding the word not to the hypothesis and the conclusion. Pause now. All right, I hope everybody got this. It should be as follows. If it does not snow, then school is not canceled. If it does not snow, then school is not canceled. The important parts, again, I put the word not in there and also there. And we have the inverse. All right, the final one is going to be something called the contrapositive. Contrapositive. So the contrapositive, we're going back to the original statement. All of this goes back to the original statement. So if it snows, then school is canceled. Again, this represents P implies Q. P implies Q. So when we do the contrapositive, this will be switch the parts and add not. Switch the parts and add not. That means we're going to be doing the negation and we're going to switch the hypothesis and the conclusion all at the same time. So our symbolic logic for that would be we are switching the order of P and Q, so Q will come first. And we're switching the meaning. We're adding the word not. So here come the squiggles. Squiggle P implies, or excuse me, squiggle Q implies squiggle P. Switch and add not. And it will be if school is not canceled, then it did not snow. The order is changed, and of course the word not is thrown in as well. This is the contrapositive. Not Q implies not P. So we have them, converse, inverse, and contrapositive. They are the important ones. So let me go back just a little bit, and we'll head back to the converse first. We started out with what we assumed to be a true statement, that if it snows too hard, we're going to have school canceled. But let's actually pay attention to the converse itself. If school is canceled, then it snowed. Are there any reasons, and I'll give you just a second to think about this, are there any reasons why school could be canceled, but we don't have any snow on the ground? Please pause the presentation and discuss it openly. There are several reasons why school can be canceled, but there's no snow on the ground. There might not be power in the building. It may have rained very hard, and there's a lot of high water. School's been canceled for that as well. There's lots of reasons why school could be canceled, but not have snow on the ground. So what we've come up with is something called a counterexample. This is an example that is counter to the statement. We only need one of them to prove that this is a false statement. A false statement. So, if school is canceled, then it snowed. That's a false statement. It may have rained too hard. If it does not snow, then school cannot be canceled. This is now the inverse. If it doesn't snow, let's say it rained, school can still be canceled. So in this situation, it raining or a power outage would also be a counterexample to this. So, counterexample. This would be an example counter to the information given. Finally, the contrapositive. If school is not canceled, then it did not snow. So basically, if we are in school, then we know it didn't snow too hard. That's a true statement. So let's sum this up a little bit. First off, if I want to look at a false statement, the only time that a statement is false is when we have a true conditional, a true hypothesis, but a false conclusion. So the only time that happens is when the hypothesis has been satisfied, but it leads to a false statement. For instance, if school has been canceled, meaning it rained, then it must have snowed. That's a false statement. Our counterexample is the rain. So, the only time that a statement can be false is if a true hypothesis leads to a false conclusion. And the other word that we need to get in here is counterexample. Counterexample. It is one situation, and you only need one, that leads to a false statement. The counterexample is one situation that leads to a false statement. All right. At this point, I'm finished. Have a good day.